All right, John here. We're here to prove the half-angle formulas, which, believe it or not, come from the power-reducing formulas that we proved in the last video. And these all originated with the difference formula for cosine. And that's what I want you to remember, is that all of these are equivalent expressions. So they all are equal, which means they're not even different. This is just a whole lot of plastic surgery to make things look different that are actually the same. But sometimes we're looking at things in different forms, and so it just makes sense to look at stuff in a different form than what we're used to looking at it in. So starting here with cosine squared of x equals 1 plus cosine 2x over 2, I'm going to let x equal theta over 2. If I do that and I plug it into this formula, I get cosine squared of theta over 2 equals 1 plus cosine of 2 times theta over 2, which these cancel. And then if I square root both sides, I get cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta over 2. And that is literally the half-angle formula for cosine. So here's the half-angle formula for cosine. We can go through the same process to find the half-angle formula for sine, and tangent. I'm just going to write them here, okay? So the plus or minus is going to depend on which quadrant we're in. So if we're in the second quadrant and we're talking about sine, then we're going to use the plus. But if we're in the second quadrant and we're talking about cosine, we're going to use the minus. And if we're in the third quadrant talking about tangent, we're going to use positive. But if we're in the second talking about tangent, we're going to use the negative. Okay? And that's which quadrant this angle lies in, obviously, theta over 2. So sometimes it's not going to be obvious which quadrant theta over 2 lies in. They'll tell you what theta lies in, and you'll have to say, well, if theta lies in the second quadrant and I'm dividing that by 2, then it has to be in the first quadrant. But sometimes it's not that easy. So we're going to use the half-angle formula. We're given that cosine of theta equals negative 3/5. And you can see here that we are in the third quadrant. So if we're in the third quadrant, let's just picture this, okay? So we're in the third quadrant. We're somewhere here. If I cut that in half, so let's say we're here, right? And we cut that in half. So 3 pi over 2 cut in half is 3 pi over 4. So we're going to end up like here. But if I have something that's over here and I cut that in half, I'm still going to be in the second quadrant. So I'm like sort of stuck in this region right here of the second quadrant. So regardless of what theta is, I know I'm going to be in the second quadrant. And I'm doing that by taking the endpoint. So pi over 2, pi divided by 2 is this point right here. 3 pi over 2 divided by 2 is 3 pi over 4, which is right here. And so I know I'm in between these two values. So I'm in the second quadrant. And in the second quadrant, sine is positive and tangent is negative. So the answers that I get here when I use the plus or minus, I should use the plus for sine, I should use the minus for tangent. So let's start by using the the half-angle formula for sine, which came from the power-reducing formula. So that's 1 minus cosine theta over 2. Again, we already decided, since we're in the second quadrant, sine is going to be positive. 1 minus cosine, which was given. So 1 minus negative 3/5 over 2. So 1 can be written as, if we use a fancy 1 here, that's 5 over 5. And 5 over 5 minus negative 3 over 5 is actually 8 over 5 divided by 2. So that's actually the square root of 4/5, which is 2 over root 5, or sine of theta over 2 is 2 root 5 over 5 if we rationalize. So that's my final answer there for sine. For tangent of theta over 2, our half angle formula is plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. And again, cosine theta was given here. We already established that tangent should be negative in the second quadrant because it's a y-coordinate over an x-coordinate. So it's a positive y-coordinate over a negative x-coordinate. So overall, tangent should be negative. So we have a negative square root of 1 minus negative 3/5 over 1 plus negative 3/5. And again, I'm going to use that trick and call 1 5 over 5. It's a common denominator. So we have negative the square root of 8 over 5 divided by 2 over 5. The 5's cancel. So we have negative the square root of 4, which is negative 2. So tangent of theta over 2 is negative 2, which makes sense. It's tangent can be greater than 1 and less than negative 1. Sine of any angle has to be somewhere in between 1 and negative 1, and so this is solidly in there. So in the next video, we're gonna start our solving of trig equations, which will be continued into the entire next lesson, which we'll do on next week. So I'll see you in the next video for some solving of some trig equations. We're gonna put together some stuff that we already know about the unit circle and factoring and everything. We're just going to put it all together. Pretty much the whole course is going to be put together in one problem or two problems.